Okay, here are some questions about statistics. Second set of questions about statistics that I'm doing some questions and answers about. More complicated things like correlation, regression, box plots. Don't know if box plots are in here actually. Cumulative frequency curves, so on and so on. So it says, on the first day of each month, a cafe owner records the midday temperature and the number of hot meals sold. So temperature and number of meals sold, and it's being made into a scatter diagram. And first question, complete the scatter diagram. The results January to June have been plotted for you, so we've just got to do July to December. So for example, 28.4, temperature is on the horizontal axis, so we've got to plot 28 across and 4 up, just about there. 27.5, so 27 across, 5 up, just about there. 23.12, 23 across, 12 up, so around there. Yep, there it is. I've actually plotted it as 24.12, so that's my bad. I'll fix that next time I do it. 18.20, 18 across, 20 up. There we go. 10.18, 10 across, 18 up. There we go. And 5.32, 5.32. Not sure whether I'd get away with that odd wrong one in an exam situation, but most of the marks there for getting most of that right. On the grid, draw the line of best fit, it says. Now, the line of best fit has an important feature that it goes through the mean point. So the mean of all the x's is 15.5, and the mean of all the y's is 20.75. So the mean point, or the average point, is 15.5, 20.75. So if we plot that point, then the line of best fit should go through that point. Now, at this level of exam, it's just a question of plotting that mean point and then trying to pivot a straight line roughly so that it has the same number of points above as below it. So there it is, in fact. Now, in higher levels of mathematics, there are ways of actually working out the best line to fit the data. It's to do with minimizing the distances, or the total squared distances of from the points to the fitted line. But we're not worrying about that. At this level, we're just plotting the mean and then just sticking a straight line as best we can by eye through that. The line I've plotted is actually mathematically the best one, but you don't need to worry about how I did that. And then what type of correlation does this scatter diagram show? Well, you've got three options. Positive correlation, if two things increase together. Negative correlation, if as one increases, the other decreases. And that's the case for this one. Or no correlation at all. But this time it's negative correlation. It goes down from left to right. So as the temperature increases, then the number of hot meals that people have decreases. Okay, so similar sort of question. The owner of a small cafe records the average air temperature and the number of hot drinks he sells each day for a week. On the grid, draw the scatter diagram. So 18.12, 18 across, 12 up. There it is. 23.8, 23 across and 8 up. There it is. Should be. Yep, there it is. 19.13, 19 across, 13 up. There it is. 23.10, 23 across, 10 up. There it is. 24.9, 24 across, 9 up. There it is. 25.7, there. And 20.12, 20 across, 12 up. There it is. Okay, what type of correlation does your scatter diagram show? So again, that's negative correlation, and just common sense tells you that should be the case, because you would sell fewer hot drinks when the temperature is higher. And then draw a line of best fit on the graph. So again, I've worked out the mean point. So the mean of all the x's and the mean of all the y's, 21.7, 10.1. And then by I, I'm just pivoting around that. But actually, I didn't work it out by I. I worked out I used least squares regression, which is a way of minimizing the distances from the points to the line. Another question. The height in meters of 200 trees in a park are measured. Okay, so there are 23 trees from 2 to 6 meters, 47 trees from 6 to 10 meters, 45 trees from 10 to 13 meters, and so on and so on and so on. Find the interval which contains the median height. So I've actually already filled in a reminder to myself that the median is the n plus 1 over tooth value. So out of 200 trees, 201 over 2 would be 100.5. So the median is not 100.5, but it's the 100.5th value. So we just need to work out which category that value falls in. So the first 23 values are in the first category. The next 47 trees are in the next category, which means that we're up to 70 trees so far in total. So the first two categories contain the first 70 trees. And then if we add the next 45 to that, we're up to 115 trees. So if we're up to 115 trees now, that means that the 100.5th tree must be in this category here. So what we have to write down to answer the question is the interval, the category, that has that middle tree. Remember, the median is the middle value when you stack them up all in order of value. And because this table is arranged in increasing order of heights, then that's effectively doing that. So we've got to write down the category or the interval 10 to 15, height higher than 10, less than or equal to 15, that contains the middle value, the median value, the 100.5th value. Okay, then it says calculate an estimate of the mean height. So the mean is add them all up, divide by how many there are. But we've got the drawback here that because it's grouped, we don't know the exact values. So we've got to make the best assumption we can about the values, which is why this is only going to be an estimate. So say the first category here, there's 23 trees in that category, and we know that they're all between 2 and 6. So the best assumption we can make is that on average, they're all in the middle. Some will be above, some will be below. It won't be an exact estimate, but it's the best we can do on the information we've got. Similarly here, between 6 and 10, there are 47 trees. Now they could all be 6, they could all be 10, but we'll take the best guess we can and say that they're all 8. So working on that basis, midpoint 4 for the first category, we're going to say they're all 4. Midpoint 8 for the second category, we're going to say they're all 8. And then between 10 and 13, the midpoint of that is 11.5. Between 13 and 17, the midpoint of that is 15. Between 17 and 19, the midpoint of that is 18. And between 19 and 20, the midpoint of that is 19.5. So all of these trees in the frequency row, we're going to assume have those particular heights. So the mean is add them all up, divide by how many there are. So if there's 23 trees that are 4 meters, that's 4 times 23. There are 47 trees that are 8 meters, that's 8 times 47. So on and so on, multiplying these out to get the total height of all the trees. So the top of this fraction is the total height of all the trees. And then I'm dividing by 200 because that's how many trees there are. 200 trees it tells you here, and then these add up to 200. So when you work that all out, it comes to 2,424 divided by 200, which is 12.12. And then just going back to the problem itself, does it make sense that the average height of a tree is roughly 12.2 meters? Well, looking at the heights of the ones we've got, that certainly seems reasonable. Okay, so bear in mind that's only an estimate because we haven't got the exact values. Then it says complete the cumulative frequency table for the information given in the table above. Okay, so the table above gives how many in distinct categories, 2 to 6, 6 to 10, 10 to 13. But the cumulative frequency table gives you a running total so far, so it adds up how many so far. So between 2 and 6, there are 23, as before. But then the next category is anything up to 10. So that's the 23 so far, plus the extra 47 in the next category makes a total so far of 70. And then 70 so far, plus the 45 in the next category makes a total so far of 115. 115 so far, plus the 38 in the next category makes a total so far of 153. 153 so far, plus the 32 in the next category makes a total so far of 185, and then plus the 15 in the next category makes a total so far of 200. So the whole thing ends up at 200, which makes perfect sense because we know there are 200 trees. Okay, next question. The table shows the height in meters above sea level and the temperature in degrees centigrade at midday for some places on a mountain. And then we've got data, which they put in a scatter graph with the height on the x-axis and the temperature on the y-axis. And then it says complete the scatter diagram for these results. The first 4, 1, 2, 3, 4, have been plotted for you. So we've got to plot the rest. So 960, 25.4. So that's going to be 960 across, 25.4 up. Paying careful attention to the units here. So horizontally, 5 squares is 100 meters, and then vertically, 5 squares is 1 degree centigrade. So bearing that in mind, the first one goes there, and then 1,125, so 1,100 is there, and then 25 is there, so that point's going to go there. 1,240 and 24.2, so 1,200 up to there is 1,300, each square is 20, so 1,240 is there, and then up to 24.2, bearing in mind that each square is 0.2 vertically, so that one goes there, and then 1,580 is up here, and 21, so over there is where that dot goes. What type of correlation does this scatter diagram show? So the options are positive, negative, or no correlation, and this is negative because the graph goes down from left to right. As one thing is increasing, the other is decreasing. And it says, on the grid, draw the line of best fit. So an important feature of a line of best fit is that it should go through the mean point. So the mean average of the x's and the y's is 915 and 26.0875 respectively. So plotting that as a point, a line of best fit should go through that point. And then for an exam at this level, it's just a question of by eye trying to make a best fit line that goes through the points with roughly as many above as below it. So just a straight line done by eye. At higher levels of study, there is a way to figure out the best fit line by minimizing the squares of the distances between the points and the fitted line. And that's actually what I've done here, but you don't need to worry about that at this level. Use your line of best fit to estimate the temperature at a height of 1,400 meters. So we read off 1,400 meters on the height, and then once we hit the graph, hit the line of best fit, we're then reading across to a corresponding temperature, and in this case that's 22.6. So I'm going to fill in 22.6 degrees centigrade. Now, of course, in an exam situation, different people will have put slightly different lines of best fit because they will have all done it by eye and not everybody will have done the same line. So it's important in the exam situation that you're showing all these working lines where you've taken the value and then read up, hit the line, and gone across to read off a temperature in degrees centigrade. So the important thing here for an exam is not so much the final value that you get, but that the person marking it can see the way you did it. So leave in all of those working lines. Okay, next question. The sweet shop owner records how much time and how much money children spend in his shop. Complete the scatter diagram. So you've got the minutes on the horizontal and you've got the money spent on the vertical. So they've done the first 7 for us. So we've got to do 14, 2.8, 14 minutes, and then somebody spent $2.80. So there's that one. We've got 15, $2.30. So somebody spent 15 minutes and $2.30. Being careful about the scale because each square vertically is 20 cents. Somebody else spent 15 minutes but $2.90, so that's going to be up here. And then somebody spent 20 minutes and $3, so up there. There it is. So what type of correlation does this scatter diagram show? So that is positive correlation because the two things increase together. The longer they spend in the shop, the more money they spend. That makes sense. On the grid, draw the line of best fit. So a line of best fit should always go through the mean average point. So if you do the mean average of all the x's and y's, you get 11.09 and 1.92 respectively. So a line of best fit should go through that point. And then beyond that, it's just a question of fitting a straight line as best you can through the data. So at this level, you're just doing that by your own judgment, by eye. But at higher levels of study, there are techniques for doing that more accurately. Common mistake is to stick the line of best fit through 0, 0. Doesn't necessarily have to go through 0, 0, and usually doesn't. Okay, a child spent $2.50 in the shop. Use your line of best fit to estimate how long the child was in the shop. So that's a question of reading across from $2.50, $2.5, until you hit the line of best fit, and then you're going to read down and estimate that they spent, in this case, 14.9 minutes in the shop. So our estimate, and it is only an estimate, is that somebody spending $2.50 would on average spend about 14.9 minutes in the shop. Okay, the next question, cumulative frequency curves, and it says 200 students estimate the mass in grams of a coin. So it's one coin and 200 students are guessing how much it weighs. Find the median. So there's 200 students. The median would technically be the 100.5th student, but when you're doing it on a cumulative frequency curve, it's okay just to go half of 200 and read across, because that little 0.5 is very hard to read the difference for anyway on a curve like this. So 100th student, and then read down. The 100th student, the middle student, has made an estimate that the coin is 3.2 grams. So the median is 3.2. Then we've got the upper quartile. So remember, the quartiles are 3 values that split the data into 4 quarters. So quarter of the way up, half the way up, which would be the median, and 3/4 of the way up. So the upper quartile is 3/4 of the way up. 3/4 of 200 is 150. So it's the estimate made by the 150th highest student, or the 150th from the bottom, I should say. So reading from 150, that goes down to 4.2. So the 150th student out of 200, 3/4 of the way up, made an estimate that the coin is 4.2 grams. So remember, the upper quartile isn't 150, but it's the value obtained by the 150th person. Then we've got the 80th percentile. So percentiles are kind of like quartiles, but instead of splitting the data into 4/4, they split the data into 100%. So out of 200 people, 80% of 200 is 160. So it's the value obtained by the 160th person. So reading across from the 160th person, 80% of the way up, that person obtains a value of 4.6. So the 80th percentile is 4.6 grams. Okay, then it says the number of students, you have to find the number of students whose estimate is 7 grams less. So this is just reading the graph the other way. So up from 7 grams reads across to 196. So 196 students make an estimate that the coin is 7 grams or less. So 196. Use the cumulative frequency diagram to complete the frequency table. So remember, a cumulative frequency diagram gives you a total so far of something. But this table isn't giving the total so far, it's giving the total in each category. So the number of students that think the coin is between 0 and 2 grams is 40. And that's evident on our cumulative frequency graph from here, 0 to 2. There are 40 students who think up to 40. And then going up to 4, there's the 40. Then going up to 4, so that's all these students, and that goes up to here, which is 140. So 140 so far means 100 extra on top of the previous 40. So the number we're filling in here is not the total so far, because it's not a cumulative frequency table, but just the total of extra ones in the next category. So that's 100. Then for the next category, from 4 to 6. So from 4 to 6 takes us up to there. Then if we read it on the graph, well, it looks like about 186. So if that reads at 186, then that means an extra 46 on top of the ones so far. So the number we're filling in this table is the extra 46 that are in the next category. Okay, then the next one, from 6 to 8, is taking us up to 198, so it's an extra 12 students. 12 students there. And then finally, they've told us that there's an odd 2 at the top. And there they are, 2 students taking us up to 200. Okay, so that's a question of converting cumulative data into categorized data. Then it says a student is chosen at random. The probability that the student estimates the mass is greater than m is 0.3. 0.3. So a probability of 0.3. So let's just think about that. 0.3 is the probability that somebody chooses that the mass is greater than a value. So we're talking about a probability of 0.3 at the top end, which means that the probability that they choose that the coin is less than that value is 0.7. Okay, so there's a certain value a certain weight, and 0.3 of the students think it's more than that weight, and the other 0.7 of the students think it's less than that weight. So 0.7 of 200 is 140. 0.7 times 200 is 140. So 140 students think the coin is below this particular weight, and the other 60 students above think it's above this particular weight. So it's a question of reading across from 140 students, and that goes down to a weight of 4 grams. So in other words, 60 students, the top 60 students out of 200, think that the coin weighs more than 4 grams. So 0.3 of the students think that the coin weighs more than 4 grams. So answer, a mass of 4 grams. The answer has to be the mass of the coin. So 4 grams is the cutoff point where 0.3 of the students, 60 out of 200, think that the coin weighs more than that. Tricky question. Okay, it says the table shows information about the heights of a group of 42 students. Using mid-interval values, calculate an estimate of the mean. Okay, so we've got a category with 5 students in, and the height of those students is between 150 and 160. Now, they could all be 150, they could all be 160. We don't know because it's just in a category, so the best estimate we can make is that they're all in the middle. Those all add up to 42, by the way, 42 students, as it tells us. So let's look at the midpoints. Midpoint of that category is 155. So our best estimate is that they're all 155. Then there's 9 people in this category. We don't know where they are in the category, but our best estimate is that they are all in the middle, 162.5. Next one, 172.5. Next one, 185. So those are the midpoints, and we're going to make the assumption that all of the students are those particular midpoint heights, which is why our mean is only going to be an estimate, because we're not using exact values. Okay, so the estimated mean is the total of all the heights, so 5 people that we're assuming are 155 centimeters, 155 times 5, plus the next midpoint times the next frequency, 162 times 9, and so on and so on. Low battery. I better do something about that. Okay, so the total of all the heights is that, and I'm dividing by 42 because that's the total of all the people. And when I do that, it comes to 171.25. There's 171.25. And just going back to the original data, that makes sense as an average height of a student. So our answer makes sense. Okay, so we're back on mains power for the next bit of the question. And the next bit of the question says, write down the interval which contains the lower quartile. So remember, the quartiles are 3 values that split the data into a quarter of the way up, half the way up, which would be the median, and then 3/4 of the way up. So the lower quartile is the value that's a quarter of the way up. Now, a quarter of 42 is 10.5, so we're looking for the 10.5th student. So 10.5th value, and then looking at these categories, so the first 5 students are in this category, and then the next 9 students are in this category. So that takes us up to the first 14 students, which means that the 10.5th student must be somewhere in this category. So the answer is the category, or the interval, which has the 10.5th student. So it's the interval height between 160 and less than or equal to 165. So it's the category that has the 10.5th student in it It's not the value 10.5 itself. Then it says, complete the histogram to show the information in the table. One column has already been drawn for you. Now, a histogram is different from just a bar chart, because the thing that shows the frequency in a histogram is not the height of the bar, but it's the area of the bar. So bearing that in mind, I've made a couple more lines, a couple more rows to my table here called class width and frequency density. So the first category has values going from 150 to 160. There it is on the bar, on the graph, 150 to 160. So the width of that bar is 10 centimeters. So I've got class width 10 centimeters. The next category has heights going from 160 to 165. So the width of that bar is only going to be 5. So it's going to be a thinner bar. The next category goes from 165 to 180. So that's going to be a much fatter bar with a width of 15. So the class width is 15. And then finally, the class width, well, you can guess for yourself before I press the button. Here it comes. 10. So I hope you got that. Okay, so the idea of a histogram is that the area of the bar is going to be the frequency, not the height of the bar. So if, for the first one, if the area of the bar has got to be 5, but the width of the bar is already 10, then the height of the bar has got to be 5 divided by 10, which is 0.5. So that when you do the height of the bar, 0.5 times the width of the bar, 10, you get 5. So that height, it's not the frequency, but it's actually referred to as the frequency density, because the frequency is not the height, it's the area. Okay, so that vertical axis on a histogram is called the frequency density. And in this case, and you can see on the one they've already done, the frequency density is 0.5 as we calculated there. Okay, so for the next one, the frequency, the number of people is 9, the width of the bar is 5, so the height of the bar has to be, work it out, 1.8. So in other words, 9 divided by 5, so that when you multiply the width times the height, 1.8 times 5, you get 9. So the frequency density is 1.8. And there's the bar itself. It's got a width of 5, a height of 1.8, and then the area of the bar is 5 times 1.8, which comes to 9. So of the particular units we're using, the area of that is 9. Okay, perhaps pause the video now, see if you can work out the next one and draw the bar. Okay, so I hope you paused it. Frequency of 18, class width of 15. 18 divided by 15 is 1.2. So you should do a bar that has a width of 15 and a height of 1.2 on this frequency density scale. And then you get that block there. And then finally, maybe pause the video again. Okay, so I hope you paused, and a frequency of 10, a width of the bar of 10 means that the height of the bar has to be 1, so that you get 1 times 10 makes 10, and then there's the bar itself with a frequency density of 1. Okay, next question. Sam asked 80 people how many minutes their journey to work took one day. And then there's a cumulative frequency. So remember, the cumulative frequency curve shows how many up to a point. So if I read 30 minutes here and 60 people, that doesn't mean that 60 people took 30 minutes. It means that 60 people took 30 minutes or less. There were 60 people who took up to 30 minutes. So find the median. So the median's the halfway value. Out of 80 people, that's technically going to be the 40.5th person. But on a cumulative frequency curve, it's sufficient just to take half of 80. So the middle person is person number 40. So reading across from 40 and down to 14. So the median time was 14 minutes. So if you ranked all the 80 people in order, then the middle person took about 14 minutes to get to work. Then it says the lower quartile. So the lower quartile is the value 25% of the way up, or a quarter of the way up. Quarter of 80 is 20. So it's the amount of time taken by the 20th person up from the bottom to get to work. So reading across from 20, that goes down to 8. So the lower quartile is 8 minutes. The person a quarter of the way up took 8 minutes to get to work. For all of these, it's not so much the final answer that's important as the way you did it. So you have to leave in all of these working lines on the graph. Okay, the interquartile range. The interquartile range is how far from the upper quartile to the lower quartile. So we've already worked out that the lower quartile, that's a quarter of the way up, is 8 minutes. So the upper quartile, 3/4 of 80 is 60. And the 60th person took 30 minutes. Okay, so the upper quartile is 30 minutes, and the interquartile range is the difference between the upper quartile and the lower quartile. So how far from the person at the top 75% to the person at the bottom 25%. So 30 minus 8 is 22. There's 22 minutes from the bottom 25% person to the person at the top 25%, 75%. Okay, the next question is very tricky. It says, one of the 80 people is chosen at random. Find the probability that their journey to work took more than 35 minutes. So the natural thing to do is to look at 35 minutes on here and read up and across to a value of 69. So common mistake would be to do something with the number 69. But bear in mind that a cumulative frequency graph is telling you how many so far up to a certain point, and the question is asking us about the people who took more than 35 minutes, not the people who took less than 35 minutes. So I've kind of shaded that in here. We're talking about the people who took 35 minutes or more. So those people are not the bottom 69, but the top 11. 80 minus 69. So there were 11 people out of 80 who took more than 35 minutes. So the answer is 11/80ths, because 11 out of 80 took more than 35 minutes. We're not talking about the 69 out of 80 that took 35 minutes or less. Okay, then the next bit of the question says, use the cumulative frequency diagram to complete this frequency table. So the cumulative frequency diagram tells us how many so far up to a point. So like so from 0 to 10 minutes, that's the first 30 people, so that's easy. But then from 10 to 15 minutes is an extra 12 people. If we look at that on the cumulative frequency graph, up to 15 minutes takes us to a total so far of 42 people. So that's an extra 12 from the previous total so far of 30. Okay, the next category is 15 to 30 minutes. So 15 to 30 minutes is is there up to 30 minutes. So that takes the total so far up to 60, which means that it's an extra 18 from where we were at the end of the previous category. Okay, so the next category, maybe pause the video and try and figure it out for yourself. Okay, I hope you pause the video. So up to 40 minutes takes us there, which is 76. So that means an extra 16 people compared to where we were before. So 16 in the box. And then finally, it's an extra 4 people, taking us up to 80, which we know is the total. Okay, then it says, using mid-interval values, calculate an estimate of the mean journey time. So once again, we've got the data in categories. So the first category has 30 people in it. They could all have taken 0 minutes or all have taken 10 minutes. We don't know. So our best estimate is to say that those 30 people all took 5 minutes. Next category, 12 people took somewhere between 10 and 15 minutes. Our best estimate is to say that they all took 12 minutes. Okay, so and so on with the midpoints of each category. So the total time taken by all the people is estimated at the number of people times the midpoint of the category. So 4 people that took between 40 and 50 minutes, we're going to say 45 minutes times 4 people. So the top of this fraction is the total amount of time taken by all the people. And then to find the average, the mean average, I'm dividing that by 80 because there are 80 people in the whole thing. So working that all out, we get to 18.0625. So our estimate is that on average, each person took 18.0625 minutes. It's only an estimate. It's perhaps a little ridiculous to put it to that many decimal places, but that's what we get. The important thing is showing the method. Okay, so the next part of the question asks us to make a histogram of that data. So it says use the table in part C. There is that table, including the bits we filled in. And we've got to make a histogram of that. So remember, the key feature of a histogram is that it's not the heights of the bar that represent the frequency. It's not the height, but it's the area. So with that in mind, I'm going to make a couple of extra rows for class width and frequency density. So the first category is from 0 to 10. They've already done the bar for us from 0 to 10. So that's got a width of 10 units. So class width, 10 units. The next bar is going to go from 10 to 15. So that's only going to have a width of 5 units. The next one goes from 15 to 30. So that's going to have a width of 15 units. The next one from 30 to 40 is going to have a width of 10 units. And then the next one, 40 to 50, 10 units again. Okay, so frequency 30 for the first bar. 30 is the area of the block. And if it's got a width of 10, then to have an area of 30, it must have a height of 3. So that 10 times 3 is going to make 30. So I got 3 from 30 divided by 10. And there it is. They've already done it for us. The frequency density is 3. Okay, perhaps you can pause the video and finish it off yourself. Okay, I hope you pause the video. So the next one, frequency of 12, width of the bar is 5, so the height of the bar must be 2.4. 12 divided by 5 is 2.4, so that we get 2.4 times 5 is 12, and then we're making a bar that has a width of 5, a height of 2.4, or a frequency density of 2.4, so that the area is 12 in the particular units that we're using. So it's not necessarily 12 big squares or small squares on this, it's just 12 unnamed units, frequency density times width. Okay, next one. Frequency 18, so that's got to be the area of the bar, width of the bar 15, so the height of the bar has got to be 1.2. 18 divided by 15 is 1.2, so there's the bar there with a width of 15 and a height or a frequency density of 1.2, making the area of the bar 18. Next one, 16 divided by 10 is 1.6, so that gives us a bar with a width of 10, a height of 1.6, giving an area of 16, which represents the frequency. And then finally, the last one, 4 divided by 10 is 0.4. So that gives us a bar with a width of 10, a height or a frequency density of 0.4, making the area 0.4 times 10, 4. So remember, with a histogram, area represents frequency, not the height.